two right now, two equations, right? You guys have done area between curves. Right, it's the integral of the top function minus the bottom function from left to right, okay? Very similar type stuff. But now we're building a shape upon those two curves. So the area between two curves we've done before, and basically what you were finding was that area right there. Well, now we're building upon that a three-dimensional structure. And it's really simple ideas, but it is, sometimes it just gets confusing as you get into it. All right, but simple ideas. Basic area formulas from middle school. Area of a square, base times base. Area of a rectangle, base times height. Area of a triangle, 1/2 base times height, etc. The key point of all of these is the base, and this is where the calculus comes in. The base is going to be f of x minus g of x. That's where the base is going to come from. So you're going to have two functions, top one minus bottom one. We're going to give you that base, and you're going to multiply that base times the height. That'll give you the area of one shape. You're going to integrate to get the areas of all the shapes added up. So if you look at this right here, there's a triangle right here. Everybody see that one? Plus that triangle right there, plus that triangle right there. Each triangle being added up. So triangle plus triangle plus triangle. Infinitely number of triangles being added up. That's the idea of what we're doing right here. So if you look at your cheat sheet, we've got about 4 examples on there. All right, so the two equations, f and g, are negative x squared plus 3 and positive x squared plus 1. And I've graphed them out so you can see them right here. What I'm building is on top of that a square, a semicircle, and equilateral triangle. And we'll build these 3 shapes on top of that. I've got a website out here too that I'm going to show you. A couple websites actually. Let me go through this one first with you. This is kind of a visual of what it is we're about to do. Might help you visualize a little better than what I've been saying, if it'll load. Internet's been so slow today. While that's waiting to load, let's work on this. So it's going to be the integral from a to b. So the integral from -1 to 1 of the top equation minus the bottom equation. In this case, the f is the top one. So of negative x squared plus 3 minus the bottom equation, x squared plus 1 dx. So top minus bottom times the height. That's our base. I missed something. That's our base right there. All of that is the base. So this is the base right here. Does everybody agree with that? That makes sense to you? So we're doing area of a square, so times the height. Well, what's the height going to be?
What do you find?
A square. What's the area of a square?
It's going to be same as the base.
Same as the base. It's base squared, right? So this whole thing is going to be squared. All right, this is the base. It's also the height, so base times base would be base squared. You okay with that?
Yes.
Making sure. You're stringing it awful hard. I want to make sure. We're talking about a square. So the base and the height are the same size. Base times base is base squared.
Where's the square coming from? Like, where are they
This square?
No, just the idea that it's a square.
So the question's gonna be asked one of 3 ways. Or one of, actually, up to 6 ways. Given 2 equations. Build squares on top of that.
Okay.
Given those same 2 equations, build a semicircle on top of that.
You can project.
Mhm.
It's good looking.
So semicircles, right?
It says it's a pin.
2 equations, semicircles on top of it. You could build triangles on top of it. It's going to be asked in one of several ways. So the base part's always the same. It's just what's the height of it. So for a square, the base and the height are the same, so it's side squared, base squared. All right, so let's simplify. That's going to be the integral from -1 to 1 of -2x squared plus 2. We agree with that? All that squared? How do we have to, what would we have to do to integrate that?
Change them.
Could you change it all? If that's your u, what's your u prime going to be? -4x. There is no x out here. I can't do that. How would I integrate this?
X cubed over 3.
Nope. Nope. Can't do that yet. You can't integrate this
Is
because
the whole thing? Oh, the whole thing's still squared.
the whole thing is still squared. So how are you going to integrate it?
So -2x squared plus 2
Change
to
it.
the 3rd power
Change
over
it.
3.
No, you can't do that. So I'm trying to get you to drive to. You can't do this. This is u. So u prime will be -4x. You can't do that. So if you can't do u prime u, what do you got to do?
Change the base.
Nope. You. That might not work on this one either. I don't know. That might work. Come on. What's your de facto thing? What do you fall back to? Algebra. What does that mean to do?
Distribute.
Foil, distribute, what do you want to call it?
Okay, this.
Algebra 1, come on. Four x to the 4th minus 8x squared plus 4, is that what y'all got? Alex, is that what you got?
Yes.
Okay. So you integrate that, and you're going to get 4x to the 5th over 5 minus 8x cubed over 3 plus 4x from -1 to 1. You should have a calculator for that just for the sake of time. you guys get? Anybody?
I got 4.3.
4.3? That's what I get as well. Negative. But that's not what I get when I integrate, so something is not quite right. Yeah, that's what we get. 4.3 said? Yeah, that's right. So. All right. Any questions before I go on? Is everybody okay what we did right there? Anybody not get 4.3?
I did not. Oh, never mind.
How do you put that in your calculator?
I did.
Well, you need to do this part because we've already integrated, so you should be doing this part right about here. So it would be 4/5 times 1 to the 5th minus 8/3 times 1 to the 3rd plus 4 times 1. That would be the first equation. The second one would be 4/5. I'm just going to do it this way. Second insert negative. Second insert negative. Second insert negative. So that one minus that one. 4.26. Now, how do you type in my calculator? The easiest way to do it is to go to y1 and y2 and plug the equations in. And then from a blank screen, math 9, or go to the bottom and look for FN int, math 9. From -1 to 1. Add some extra parentheses in there because you're going to need them for the squaring. Okay, and it's going to be vars, y vars 1 minus vars, y vars, y2 squared. If you do it that way, you guarantee your sign's right and everything. Okay, be good? And technically it's not 4.3. What is it? Let's be accurate. 4.266. It's an AP test. Get used to it. Okay. So, what have I done there? Let me try to show you visually what I've done there. I've got this idea of creating all of these different squares and summing them up along that curve. So the area of that one plus the area of that one plus the area of that one plus the area of that one. And what I wrote out here to help you visualize some of this stuff is, see this C out here beside the topic today? We got C's by these guys. I wrote some calculators out here. Let's see if this will work. So your top equation, what was the top equation?
Negative x squared plus 3,
And the bottom equation?
x squared plus 1.
X squared plus 1. When you're typing it in, you must use rooftop and the kind of hard to see there, but rooftop and so negative x squared like that. And so if I'm going from negative 1 to 1, is that what I'm doing? Negative 1 to 1. If I graph that, you can see that the green and the blue are the bases, and on top of that we're building rectangles on top of it. You can kind of watch them paste along there. I might scale a little different.
Did you make this program?
I did. I was trying to, this is a tough topic here. I was trying to help people visualize what's happening here. This one's not as bad. The volume rotation is the one that really gives people a hard time, but this one gives people a hard time too. We got to scale a little bigger so maybe you can see it better. There we go. So now you can see each piece. And you're just summing up every one of those areas. All right, so that was building a square on top of it. What if I want to build a semicircle? So if you look at your formula chart right here, this is a little screwy. And people always screw this up. So the area of a circle is what? Let's go. Pi r squared, right? Problem is, what's r? What is r in this case?
Base over 2.
Base over 2. Why base over 2?
It's the diameter.
Because base is the diameter and we want the radius. That's exactly right. So
Sounds
it's
so smart.
base over 2. So this, that's your radius right there if you want to put an r right there. Base over 2. And so if we think about what's going to happen right there, that's really going to be 1/2 pi base squared over 4. Do you agree with that? Think about that. Base over 2 times base over 2 would be base squared over 4. That makes sense to you? And so that's really going to be 1/8 pi base squared. I'm walking through this so you can understand where we're going with this. Does that make sense to you?
Yes.
So this is what we're going to want to integrate over here. It's 1/8 pi base squared. And base is going to be the top equation minus the bottom equation again. That's going to wind up integrating. So if we look at this, we're going to go from -1 to 1 again. But given what we just saw right there, it's going to be 1/8 pi from -1 to 1 of, well, guess what? Everything you just did. It's still our b, right? That's still our, this equation is not ever changing. It's still just the first equation minus the second equation And because the math we did down here is going to be b squared. So this is going to be squared again. Do we already know what the interval from -1 to 1 of this is going to be?
Yes. We do, just, we had not times 5.
This part's going to be 4.266 again, right? Everybody agree with that? It hasn't changed, right? It's the area going from -1 to 1 of all this stuff. Now let me make sure I haven't lied to you about anything. Because I would hate to lie to you about something.
Oh, this is so cute. You know?
Yep, okay. So I have not lied to you about anything. So we get approximately
1.676.
1.675. 676, what's it gonna be? 675, 676?
You round up, right?
Don't round
You
up.
don't?
You can round up.
I rounded.
It's better just truncate, and you know you're not gonna make any rounding errors.
There you go.
All right, so there's a semicircle. You okay with that one? Because that's a tricky one.
That one was easy.
It was easy because we've already done the math.
What if we done it first?
That's why we didn't do it first, okay? And then equilateral triangle. Well, equilateral triangle is right here. This is an equation you need to memorize. This is one you probably do not have committed to memory. That's what you need to memorize. Square root of 3 over 4 s squared. So this, if you notice, the square root of 3 over 4 is a constant. It's going outside. What's going inside?
S squared, which is base squared.
It's exactly the same stuff, right? It's identical. And we've already done this math. We know what that is. So our final equation is going to be square root of 3 over 4 times 4.266. $1.847. We're going to do this second piece down here tomorrow. Okay, we'll do those 3 examples. We're going to do this example tomorrow, where we build, instead of perpendicular to the x-axis, we're going to build perpendicular to the y-axis. All right, let's try some out. See how it works. They weren't nice to you. They didn't give you where to start and where to finish. You had to figure those things out. Hopefully you recognize the equation. If you don't, ask your teammates at your table and see if they recognize the equation.
Three.
Radius is not 9. Radius is what?
I knew that.
What's radius? Radius is 3. It's always helpful to draw a picture of these problems. And the origin's at 0. How come the origin's at 0?
There's no,
Plus or minus is right. There's no x minus h, y minus k, none of that stuff. Right, if it was shipped, it would look like this. That'd be right 2 and down 3. Not shifted, so. So where's our bounds of our integration going to be? Negative 3 to 3. Keep talking.
The base would be 6.
Base would be the base is always changing. Base is always what?
Oh, wait, the base is the
Base is always what?
minus the bottom.
Yeah, top minus bottom, F minus
So,
G.
is that just gonna be, is it giving us F minus G already? Or no?
You tell me.
Yes.
The whole base, the equation is the whole base.
Why do we only have one equation?
You really have 2 equations if you'll think about it.
Y equal X.
Get into y equals form, then you have 2 equations.
Didn't we solve for x too?
No. So F is what?
X plus 3 minus X minus 3.
Square root of 9.
Or 9 minus x squared. G is what?
Negative square root of 9.
Can you do anything with these?
Can't you simplify them?
Tell me how.
3 minus X and negative 3 minus, and then 3 minus X is negative outside of it.
So you're saying that what you're telling me, if that's true, is that
We have a negative x.
doesn't matter. What you're telling me, if that's true, is the square root of 4 plus the square root of 4 is equal to the same thing as 2 plus 2. Is that a true statement?
No.
That's what you're trying to tell me right now. Square root of 4 plus square root of 4 is square root of 8. Square root of 8 is not 4.
Oh, it's 3 plus 3 plus x times 3 minus x.
You could do that, but does that do anything for you? Under square root sign. You could do that, and there's nothing wrong with it. Does it do anything for you under square root sign? I need you to see this, right? I mean, because you're on an AP test, you're under a time crunch, right? Your first thought is I factor this, but does factoring help you out under square root sign? Difference of squares. Does difference of squares do anything under a square root sign? Doesn't do anything for you. The only time that you can reduce something in a square root sign would be this. That's gonna reduce, because why?
Square root and square root.
The entire term is squared, so the square root and square cancel. But the entire term actually is squared if you go do anything with it. If just a piece of it's squared, don't get lost in it. You're done with it. You can't do anything else with it. Okay? So F is the top equation, G is the bottom equation. You can't simplify any further. So I'm integrating. I want to build squares on this, right? So what's my formula I'm going to do right here?
F minus G.
F minus G
Squared.
squared. So can I integrate this? If that's my u, my u prime would be negative 2x. Do I have any x's outside? I can't integrate that, so then I have to fall back and do what?
Algebra.
Distribute. It's my algebra, right? Rewrite this thing so you can. What can I do? Algebra 1, what can I do? Give me what?
4 times 9 minus x squared.
Right, I mean, what you're saying is I've got this times itself. So, if you want to think about it that way, you can. So you can either distribute that 4 or bring it out in front. Whatever you want to do is fine.
Why do we have to integrate the 4?
It's a constant. You could have distributed the 4 and then integrated. And then you would have had 36x minus 4/3 x cubed. 4/3 x cubed. And that would be fine too. It really makes a difference on that one.
Okay.
My default is always take any coefficients outside, because I feel like most of the time it makes life easier. What do you get, Cameron?
I got 144.
So just to practice your calculator skills, let's see if it is 144. Let's go back to this right here. To plug these into F, into Y1 and Y2, and verify that you get 144 with your calculator doing the actual integration. Because these questions are by half and half. Half of them are calculator, half of them are no calculator. So we need to have our calculator skills. So 9 minus x, plug it in please, 9 minus x squared in your calculator, into Y1. Negative 9 square roots of 9, no, negative square root of 9 minus x squared. So there's Y1 and Y2. So math 9. Negative 3 to 3, parenthesis, bars, y1 minus y2. Close your parenthesis and squared. Be good? Do the second one.